The role of MVM OVIT Zrt in the establishment of the Hungarian GSM-R system. To establish the GSM-R system in Hungary, the National Info Communications Services Company published a call for tenders, which was won by the consortium formed by the MVM OVIT Zrt and the Capsch Carrier Com Kft. Within the scope of the project, the consortium had to establish the GSM-R network over a railway line section with a length of nearly 935 kilometers. In addition, development provides the opportunity to implement a technical communication platform in Hungary required for the installation of an ETCS-L2 level safety system. In the consortium, MVM OVIT Zrt was responsible to design, establish the infrastructure servicing the GSM-R network, to manufacture and erect the telecommunication towers, to supply the outdoor telecommunications cabinets. During the design phase, 100 engineers were working together. The design engineers participated in designing the radio and fiber optic network and the associated architecture, supporting structure and the power supply. For controlling the network, it was necessary to design the infrastructure of 2 telecommunication centers, whereas the operation of the radio network required the design of nearly 150 base stations and more than 200 transmission technical rooms and dispatcher stations. MVM OVIT Zrt erected antenna towers along the railway lines at 122 locations with a height ranging between 20 and 50 meters. During their installation, nearly 6,000 cubic meters of concrete and more than 600 tons of steel were used. The tower structures were fabricated in a special steel manufacturing plant of MVM OVIT Zrt, satisfying the needs of the energistic industry. For the event of an emergency service interruption, the consortium had to deliver 2 mobile base stations as well. As its main purpose, the mobile base station provides continuous standby state and, if it's necessary, by arriving at a location to provide the opportunity to restore the coverage within the shortest time possible. At the site of the base station, more than 240 telecommunication cabinets were installed. The cabinets accommodate telecommunications, property protection devices, air conditioning and power supply equipments. The cabinets were assembled in a central substation construction plant of MVM OVIT Zrt, from where they were delivered to the site in a fully assembled condition. In the outdoor and indoor cabinets, totally 380 pieces of uninterruptible power supplies were installed. It meant the putting into operation of exactly 1,480 chargers, 3,342 batteries of a total weight of 140.5 tons. One control center of the network was built at the Budapest-based Horog Street site of the MVM Zrt. The above-average availability of the network control center can be provided by the power supply connected to the 2 standalone medium-voltage electric networks, the established uninterrupted power supply system and the 2 diesel power aggregates installed next to the building. In the center, 1,920 optical arrangers suitable for optical termination were installed, which are able to serve the perspective needs as well. The events of key importance can be monitored also on the lead wall placed in the network control room. The other control center was formed in the building of MÁV station at Székesfehérvár. From operation aspect, the Székesfehérvár center is the exact replica of the Budapest center. The National Info Communications Services Company published a separate call for tenders for the construction of the optical network. As a result of the call for tenders, MVM OVIT Zrt could establish the optical network over nearly 600 kilometers, satisfying also the prospective needs of the railway companies. During the installation, the construction teams were working simultaneously at several sections too. In the course of their work, they moved more than 100,000 cubic meters of earth. In the certain periods, more than 90 work machines were operating at the sites, and it was not uncommon to implement a track length of weekly 25 or 30 kilometers. During the construction, the experts of MVM OVIT Zrt laid protective tubes of nearly 2,900 kilometers into the prepared track, into which they pulled optical cables in a length of nearly 1,300 kilometers. To implement the optical network, 410 pieces of optical arrangers and 480 pieces of optical connecting fittings were installed. To carry out the measurements before the delivery, the consortium implemented a measuring wagon equipped with measuring instruments, terminal equipments, antennas, in accordance with the regulations. At the established workplaces, the telecommunication engineers may monitor the network measurements, and if it's necessary, they can optimize the network's operation even remotely. During the network's optimization, the members of the measuring team travel through the railway line sections several times with the measuring wagon, as long as the network, as a result of the continuous optimization, meets the specification required in the standard.